Hey everyone, how's it going? In this video, we're going to work through an example using related rates. The problem says, a rectangle is drawn inside a right-angled triangle as shown in the diagram below. Point B moves along the base of triangle AC, beginning at point A at a constant speed of 3 centimeters per second. At what rate is the area of the rectangle changing when point B is 20 centimeters away from point A? So basically, let's kind of review what we're told. This point B right here is moving away from point A at 3 centimeters per second. And what we want to know is what the area of, or how the area of this rectangle is changing at that point when B is 20 centimeters away from A. Okay, so let's start off. What is area of a rectangle? Well, that's an easy question. Area is just base times height. Okay, but one thing you have to think about when we're doing related rates is that we want to rewrite everything in our equation using the same term. So I'm going to try to rewrite B and H in terms of Y. So how can we write B in terms of Y? Well, let me draw out this big triangle right here. It's going to look a little like that. We have a 50, we have a 30, we have a 90 right here. So what's this missing angle? Well, 30 plus 90, that's 120, means this has to be 60. Okay. Now, if you're unfamiliar with 30, 60, 90 triangles, let's go over them real quick. So they're kind of like a special identity triangle. If we have 30 here, a 60 right there, and a 90, and let's say opposite of 30 we have some side length s, then opposite of 60 it's going to be s root 3, and then opposite of 90 we're going to have 2s. So we can kind of use this triangle to fill out what these two sides are going to be. Opposite of so if opposite of 90 we have 50, opposite of 30 we have to have half of that, so it's going to be 25. And then opposite of 60 we have 25 square root of 3. Awesome. So what do we just find out? We just found out that the distance from here to here is 25 root 3. And if this distance is B and this distance is Y, then I can just describe the length of B as being 25 root 3, so the entire distance minus whatever Y is, right? So I'm going to write B is equal to 25 root 3 minus Y. Awesome. So now it's in terms of Y. Let's do the same thing for H. So for H, I'm actually going to just look at this little triangle right here. So if I have a triangle like that, where this is also 30, 60, 90, then if this is Y and this is H, well, it says if we look at our kind of generic triangle, opposite of 30 is S, opposite of 60 is S root 3. That means Y is root 3 times H. So if I want to write H in terms of Y, I'm just going to get Y over root 3, because H is equal to Y root 3, Y is equal to H root 3, so then you just divide both sides by root 3, and we get H is equal to Y over root 3. Cool, so now we have both B and H in terms of Y. Okay, so now this problem's asking at what rate is the area changing? So in order to figure that out, we have to find out what the derivative of the formula for area is. So what we're going to be looking for is A prime. And when we're looking for A prime, you see this is something times something. So we're going to have to use the product rule, actually. And the product rule tells us that A prime is going to equal B prime times H plus H prime times B. Not too bad. Now let's just fill in what we know for B and H. So we get A prime is equal to B prime. So that's just going to be 25 root 3 minus Y prime times Y over root 3 plus y over root 3 prime times 25 root 3 minus y. Awesome. Now, let's simplify some of these derivatives. We get, well, the derivative of a constant is 0, so this cancels out. The derivative of y is just y prime, so we get negative y prime times y over root 3 plus y prime over root 3 times 25 root 3 minus y. So now that we have our equation for area, or the rate of change in area, we have to figure out what we plug in for y. So the problem says, at what rate is the area of the rectangle changing when point B is 20 centimeters away from point A? So when the distance from A to B is 20. Well, that's pretty much just saying when y equals 20. So that's simple. We're going to evaluate at y equals 20. But we have to find out what y prime is when y equals 20. So how is y changing when y equals 20? Well, it says that the distance from A to B is changing at a constant speed of 3 centimeters per second, which means that regardless of whether y is 1 or y is 100, the change in y is still equal to 3. So our y prime is equal to 3. Perfect. So let's plug this in. So we get a prime is equal to negative 3 times 20 over root 3 plus 3 over root 3 times 25 root 3 minus 20. Let's evaluate this a little bit. So we get a prime and then negative 3, that's just negative root 3 times root 3. So root 3 and root 3 cancel, giving us negative 20 root 3 plus 3 and root 3 cancel out similar to this, giving us root 3 times 25 root 3 minus 20. So now we get a prime is equal to negative 20 root 3 plus, now root 3 times 25 root 3 gives us 25 times 3 minus 20 root 3. And we get negative 20 root 3 minus 20 root 3 gives us negative 40 root 3 plus 75. So as you can see, this is how our area is changing when y equals 20. I hope this video helped. If you have any questions, let me know. And as always, happy studying.